I think these two questions are probably the weirdest. 11 and 12. They're not too bad though. It should be okay. Let's have a look. A compound with a molecular formula of NXHY is 87.4% nitrogen by mass. A sample of this has a density of blah 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 blah. Determine the molecular formula. Wow, that's just lovely. Okay, now this okay, it's gonna be fun trying to explain this question. So you start with molecular formula. You know there are two. Now, well, the difference between a molecular formula and an empirical formula is that empirical formula is the smallest ratio possible between the number of atoms of each element that are present in the molecule. So the smallest ratio, and the molecular formula is the actual number, actual amount of atoms. So just, that's not an M. Just for an example, I could say CH2 would be an empirical formula because 1 to 2 is the smallest ratio that you can have. But things like C2H4 or C4H8 would be examples of molecular formulas. Now, if you want to determine the molecular formula of something, let's say, first of all, they give you, so that's what molecular formula, and NXHY. So this is probably a very important piece of information. They give you the type of elements that are present in this molecule. So we have nitrogen and we have hydrogen. And I think I just deleted. 87.4% is nitrogen by mass. So the percentage composition of this element is 87.4% nitrogen, which means that the remaining percentage has to come from hydrogen, because if you look at the formula, there are only two elements present. So 100 minus 87.4, which is something, I may have made that up, 12.6% is hydrogen. Is that even right? I'm kind of paranoid sometimes, so it is right. Okay, I should have trusted my mental maths. Right, so 87.4% is nitrogen, 12.6% is hydrogen. You also know that a gas sample, again, the word gas is probably very important here because it means that I am allowed to use PV equal to nRT. It is a pure substance after all. It has a density. Now, it's always interesting when they give you these kind of values and you're like, what am I going to do with it? So density is a ratio between mass and volume. So 0.977 grams over 1 liter is going to be the density of this gas sample of this compound. And it has this density at temperature of 100 Celsius degree, and pressure, ATM, sorry, the unit is supposed to be here. Pressure is 0.93 atmospheric pressure. And then you need to determine the molecular formula of NXHY. Okay, now the percentage composition should allow you to determine the empirical formula. So I would say I'm going to start with empirical formula because I kind of need to start somewhere. And when you have to find the molecular formula, the empirical formula is always the first thing that you want to find. And once you have the empirical formula, in order to go from there to the molecular formula, you need to be able to find the molar mass of the gas of the sample. The molar mass of the empirical formula is going to be, sorry, the actual molar mass is going to be a multiple of the molar mass of the empirical formula. So I think step 2 is I'm going to have to find the molar mass of this gas somehow. Now molar mass is mass divided by number of mole. Okay, so because I have the density of the gas, I should be able to find mass. So 2A is, I need to find mass if I have the volume. Well, if the volume is 1 liter, so if we assume if V equal to 1 liter, then mass is 0.977 grams. So this is very interesting. The question doesn't give you information regarding the volume, but you can just pick a volume. If I pick a volume of 1 liter, every liter of this gas has this density anyway, so I'm going to use 1 liter as a volume. Okay, and then I get the mass, and then I guess 2B is going to be using PV equal to nRT to find N, and using volume of 1 liter. You definitely can go with volume of 10 liter if you wish. You're just gonna have a different mass and a different number of mole. So N is going to be PV over RT. And lastly, I'm going to find the molar mass, because I would have at that point mass and number of mole. Once you've done 1 and 2, you should be able to work out the empirical formula. So 3 is that, but there's no room here. So we're just going to go back to step 1, finding the empirical formula. I hope that made some sense. I try to explain my thought process, but sometimes it's not easy, especially if I write out exactly what happened in my head. It tends to move by quickly. So empirical formula step 1, I'm going to write out the elements that are present. So I have nitrogen and hydrogen. The percentage is 87.4% of nitrogen for 12.6% of hydrogen. If you assume that you have 100 grams of this substance, it means that for every 100 gram, I would have 87.4 grams of nitrogen and 12.6 grams of hydrogen. So that's a simple way to convert percentage to mass. I will now try to find the number of mole by dividing these masses by their respective molar masses. So I get 6.24 for nitrogen and 12.6 for hydrogen. And if you divide by the smallest mole, which in this case is the number of mole of nitrogen, so 12.6 divided by 6.24, it is a good idea to try to keep the exact value in your calculator as much as possible. But I get a 1 to 2 ratio, very close to that. So I would say the empirical formula is going to be NH2. So hopefully my molar mass for the molecular formula that I'm about to find is going to be a multiple of this. I'm just going to find right now that the molar mass of NH2 is 16 grams per mole. Okay. All right, step 2 is going to take a while. So, oh yeah, no, actually won't take that long. So we assume, as we said before, we're going to assume the volume is 1 liter. You have to just make a call. It doesn't really matter, because if you change the volume, you're going to change both the mass and the number of mole of the substance, and the molar mass is not going to change. Anyway, if you have that volume, then the mass is, what is it, 0.997 0.977 grams, I mean. Okay, I need to find the number of mole. So I think before that, I do need to do a few conversions of unit. First one is temperature. Seriously, I think I have short-term memory loss. I can't remember anything. 100 Celsius degree, and this P is 0.93 atmospheric pressure. Yes, yes. Okay, really do have short-term memory loss. So 393 Kelvin. Temperature has to be converted to Kelvin, and pressure has to be converted to kilopascal before you can use a universal gas equation. So if they do that, I get like around 94.209 kPa. All right, so number of mole is going to be PV over RT. R is the universal gas constant, which is 8.31. 209 times 1 liter. It's always good to use number like 1, it's easy. 8.31 times 393. So number of mole, what did I just do? Okay, not sure what I did there, but I just went to question 12, which is going to be fun to explain. Another video though. 393. So we get 0.0288 mole. Okay, step 3 is C. 2C is going to find the molar mass. So mass over number of mole, and I'm praying here that it's going to be a multiple of 16. Otherwise, we have done something wrong, and I have to try to go back and fix it. Oh, that's just lovely. I got 33.8 0.68 grams per mole. What does that mean? Okay, we're gonna see. Step 3 is to find the molar mass. So if we go with 33.868 over 16, that's approximately 2.1. I think I'm gonna have to accept it because did I make a mistake somewhere? There is a possibility of we making a mistake, but 2.1 is not that terrible as a ratio. I think one of the things that you guys need to really keep in mind is that you're not going to get a perfect ratio most of the time, because when you measure quantities, the values are not exact. So I'm going to go with 2, which is approximately 2, which means that the molecular formula, I think they rarely do this in actual assessment though, because it freaks student out when if it's 2.6, you probably have done something wrong, but I'm going to label 2.1. And the empirical is NH2, so molecular formula is going to double that, which is N2H4, and I think that's fine. Okay, that's that for that question, and we're gonna record this.